Well, good afternoon, Cohort B. Great to see you looking so wonderful today. Just like me, my hair is really curly today. I know you appreciate that. So it's one of those good days. It must be humid or something today. Anyway, listen, it's not a very long lesson today. The students had about half the period to work on their own today, so I'm just going to explain what they did. It won't take me very long to explain it. So let's just talk about first something that comes up in the homework. Okay, and it's about the minimum requirements needed for an electric circuit. So just let me explain that to you. Number one, for an electric circuit to function, you have to have a power source. So in this case, it's a battery, as you can see here. Okay. Number two, you have to have wires. So those red dots are representing the electron flow. Well, those charges are flowing through a conductive path, and that's usually made of wire, most likely copper, okay, is the wire of choice that we typically use. It's a fairly abundant metal, okay, and yeah, copper. So one is a battery, two is a copper conductor, three, okay, is the light bulb, and here you can see the light bulb turning on and off as the switch gets open and closed. So the deal is with the light bulb is you have to have some device of some kind in the circuit that's using the electrical energy. You can't just have wire. Okay. Now you can have wire. We call it a short circuit if it's only wire in the circuit. A wire has a low resistance, and you would draw a lot of current from the power source. So it's kind of a dangerous situation depending on your power source. But you know, you're either going to drain your battery very quickly with a short circuit. That's a circuit without a load in it or without a device in it, just wire. Or you could even potentially melt the wires or draw, like if you did that to a car battery, you could get a dangerous shock from it. So look, you have to have a device of some kind in the circuit. In this case, it's a light bulb, but it could be anything. It could be a toaster, it could be a computer, it could be your cell phone, it could be a cell phone charger. Okay, whatever the device is that's using the electrical power. Okay, so that has to be in the circuit as well. And then finally, there is a switch in this circuit. Okay, the switch isn't absolutely necessary. So for example, when you plug in your cell phone directly to the wall, there's no switch. You just plug it in, and all the time that it's plugged in, that charging system can be active. Okay, you don't have to plug it in and then flick a switch for it to work. So some devices like light bulbs and stuff, switches are nice, and you don't want to have to unplug your light every time you're not using it. So we like to wire up lights to switches. It makes it more convenient. But the switch isn't, my point is, the switch isn't absolutely necessary. So there's a question in your textbook that says, what are the minimum requirements necessary for an electric circuit? So there are three things, that's my point. One is a power source, two is the wire, the conductive path, and three is a load, so some kind of device that's using the electric power. Okay, so that's it for that. All right, well, let me get to the homework outline here for a moment. Jacob, you'll be pleased to notice that I actually crossed out some homework here, and I'm glad you didn't do it yet, because, you know, I told you not to do it for homework, so I'm glad you would have followed my instructions and not done it. The calculations, please, by tomorrow, please have finished the calculation worksheet that I gave you, okay? So please have that done. And that's for tomorrow, okay? So I don't want you to do the textbook questions that were assigned behind that black mark there. Just the calculations, that's good enough. Okay, and then we've actually covered these three items already, okay? So we've done voltage, we've done, like yesterday we covered most of this material, and that question that I just showed you with the load and the wires and stuff like that, with the three components of a circuit, okay, the wire, the power supply, and the load. Okay, just keep those three things in mind for one of the questions I think that's in the homework, a couple of them maybe. But other than that, these are questions, not calculations, but just about your understanding of voltage, current, and so on, and power. Okay, so when is this due? The three things I just highlighted, that's lesson number 8. when is it due? Like whatever. Let's make the homework, the textbook homework that I'm going to assign today is going to be for Monday. Okay, it's going to be for Monday. All the homework that I assign, or not for Monday, I guess for you. Let's say Tuesday. But anyway, you have the weekend to do it, and I won't be assigning a lot more work over the weekend. So there'll just be another lesson tomorrow, and then that's basically it. So let's get right to it. The new assignment, actually here, before we move away from this, today we're going to be talking about energy resources. These are the things that we use to generate electricity, okay? In your textbook on page 518 to 527, you will see various things that we use to generate electricity. I'm going to do one of them with you today. So I'll describe one way of generating electricity for you in the notes, and I'll show you what I expect, okay, as a result when I show you this, and you'll know what to do yourself then. And then you write down the pros and cons. I'm asking students to try to find 3 pros and 3 cons. So a pro means in favor. So what that resource has in favor, okay, that makes it a good thing. Let's say solar power, for example, is renewable, right? Which means that it is a resource that doesn't run out, because the sunlight doesn't run out. I mean, well, it runs out in 4.5 billion years, but you know, that's basically renewable. It's basically around forever for all of human existence, let's say. Okay. And there's just 4 questions here on this page that we're going to add to as well. So that all of that I highlighted in yellow, we're gonna save for Monday. But I would like you to finish for tonight. Okay, please focus on these calculations. Make sure you get those done, and then you're probably going to want to start some of this. So but you're going to break it up so that you know, you'll have some of it to do on the weekend, and maybe do a little bit every night. But guys, you know, you shouldn't be doing more than maybe an hour's worth, okay, in a day. So just keep that in mind. All right. So let's get to the assignment on energy resources. Okay, so in your textbook, you will see various resources described. I wrote them down here in this weird rainbow color. I thought it would turn out differently. Maybe I should change this. Where's the rainbow color? Oh, this one here. Here, I'll use that one. Okay, so look. There's wind. There's hydro. Okay, and there's solar. Now, these 3 resources together are all 3 renewable resources. Wind is when you use with the wind itself, the blowing wind, to spin a turbine. So we talked about that when we talked about generators when you guys were in class with me yesterday. Hydro is where you use the movement of water to spin a turbine. Okay, so that's another way to do it. Solar is the one that has no moving parts, so it does not use turbines. That's when you use sunlight to create electricity in a solar panel, and then that electricity can be used to power different devices, whatever it is you need to do. Now, thermal generation, thermal is when we use heat to heat up usually water to a very high temperature. You create superheated steam under pressure, and that pressurized steam can create a kind of wind inside of a sealed compartment where there's a turbine, and that will spin the turbine. So you can use the pressure of heated steam to spin turbines. We call that thermal generation. So what are the various ways that we use to create heat for that? Well, coal is one way. That's the worst way by far. Okay, it's very harmful to the environment to burn coal. So we really want to stay away from that one. But some places, like I was telling my students today, if you live in Australia where they use a lot of coal-fired plants to create electricity, and you buy a Tesla or any electric car in Australia, thinking that you're doing the right thing for the environment, think again. What you're doing is you're replacing the energy that you're using to charge your battery in Australia as coal power. Coal as a fuel is extremely toxic for our environment. Okay, so you're actually better off just buying a gas car. In terms of the planet, that is, in terms of our environment, you're better off just having a gas car if you live in Australia, because your source for charging your battery is dirtier than the octane would be to burn in your gasoline-powered car. Okay, believe it or not. So in Ontario, that's not the case. So in Ontario, 90%, 93, I think, 94% of the electricity we generate is carbon-free. Okay, so it's a pretty good deal. Well, not carbon-free, but has basically zero emissions in the process. Okay, there may be some emissions in the mining and everything else, but we'll talk about that shortly. Finally, nuclear power. Most of the power we generate in Ontario is nuclear powered, and so this one's an important one for us. And it just so happens that that's the one I'm going to do for you. So I would like to make this clear. I'm going to do one of them for you, so you don't have to do it yourself. Okay? So the one I'm going to do for you is nuclear power. So I had some pictures I'm going to show you when you come to class tomorrow about this. But yeah, let's just get right to it. Let me show you what I expect for nuclear power. First, I'm going to erase some of these highlights and we'll just talk about it as we go. Okay, and I'm going to erase this also. And then I'll erase that too. Okay, I'll erase this line, just a few lines here. Okay, that I had highlighted and circled. Okay. All right, so let's talk about nuclear power for a moment. So here you see this. I'm gonna zoom out so we can read more of the paragraph. Okay, so what is how do we generate electricity with nuclear power? Well, the process is pretty straightforward. What I want you to do in the assignment is write a short paragraph the way I did here. Okay, and the paragraph gives a basic grade 9 level description, okay, of the process that's creating the electricity. Now, it needs to be grade 9 level. I don't want to see, like if I Google how does nuclear power work in a power plant, you can get the, the graduate level physics version of that online if you Googled it. I don't want to see that from you. What I want to see, it's all in your textbook. So if you just look at the textbook, you can find this information. But I want it in your own words. Okay? So I wrote this in my own words. Okay? And so, like, that's what I want to see from you. And you're going to do each single one of you. I don't want you to, it's not a group project. I want each of you to read about each of these resources, and I want each of you to learn something from what you've read. That's my goal here. So in the case of nuclear power, this is what I did. Yeah, open up your textbook, find the page where it talks about nuclear power, and I indicated the pages in the course outline. It's under the subheading of thermal energy, because you'll see why in a moment. But anyway, let's talk about this. Nuclear energy. Nuclear energy is contained in the nucleus of an atom, okay? And the energy can be released in two ways. Now, we've looked at these two ways already, fusion and fission. Okay, so nuclear fission is the splitting of atoms. And in fact, nuclear fission, this one here, is the primary, well, it's pretty much the only way that nuclear power plants generate electricity. We don't use fusion. Fusion is used in nuclear bombs, okay? But we have not had a reactor that's able to efficiently produce electricity for us in the case of a fusion reaction. Fusion reactions need to get extremely hot, and so it makes it not cost effective. Okay, so far, if we could get cold fusion to work, that'd be different. Now, I did explain fusion here, and fusion energy is released when atoms are combined together to form a larger atom, and that's when you add protons to the nucleus. Okay. In nuclear fission, though, atoms are split apart to form smaller atoms, and they release energy in the process as well. Nuclear power plants use fission, so they use fission to heat water to produce steam. The steam is then used, okay, and this is common to all thermal generation. The steam is used to spin large turbines that generate electricity. See, you can use nuclear power to heat the steam, or you can use coal, burn coal, or you can burn methane. That's a natural gas power plant. Okay, and that's how we use thermal, which means heat, to create electricity. Now, I found this picture online. I want you to find a picture online, so please include photos. Just one photo is enough, and you can just Google it, like, coal power plant. Just Google it, see what you come up with, and, what I wanted to point out to you, though, is this. If you think nuclear power is dirty, you see these huge smokestacks. That's actually water vapor. It's H2O. Okay? That smoke coming out, it's not a greenhouse gas. It's not carbon emissions. That's one of the pros of nuclear power, is that its carbon emissions are basically zero, at least in terms of day-to-day operations. Okay, so here's a little schematic I found online. So you can find these images online and just paste them into your documents. Okay, remember, I'm doing nuclear power for you, so I'm trying to explain to you what it is I would like you to do. Okay, now here's the deal. How does the plant work? Well, this little schematic diagram kind of says it all. And, you know, if you were doing coal fire generation, what you would do is you would just replace the nuclear reactor, okay, with something that burns coal or whatever. But then, of course, there'd be an exhaust valve for the emissions from that, from the smoke from burning the coal. But nuclear power does not produce smoke. Okay, so let me explain what's happening. I'll highlight it in yellow. This thing here that I just highlighted is the core. Okay, it is where the nuclear fuel is stored, and nuclear fuel is usually uranium. It's enriched uranium. Like I said, IL-12 at Costco, enriched uranium isle. And what happens is you put that fissile material. Okay, so like in other words, like it can undergo fusion in the core, and if you get enough of that mass together in the core, the atoms will split sort of spontaneously in a chain reaction and release a tremendous amount of energy. Now, it's not like a bomb going off. The reaction is controlled, and it's controlled with these rods. Now, listen, I don't want you don't have to explain all this in your notes, okay? I'm explaining it to you because I'm the teacher, and I want you to I want to have a little fun with the nuclear power to explain in a little more detail. But in the assignment, like I'm just talking right now, if I didn't write it down here, then you don't have to include it, okay? So I just want to explain it. Even if you don't quite get these diagrams, that's okay. I want you to include one, and I'm going to explain this one to you. So look, the core is what gets hot, okay? So the core gets very hot. That's where the nuclear reaction is taking place. And what happens is that heat, it heats up water, is what I told you before. In this case, I think it's heavy water, that goes in through this pipe here that I'm just outlining in black. It goes in there and gets circulated through that system. Now, there's another system of water that exists outside of that. I'll circle it in blue here. That tank of water there, okay, will get hot as well. And that superheated steam travels up through here, spins the turbine that you see right there, and that creates the electricity that we have. Now, this water can be extremely hot. The steam can be extremely hot. And so, like, we cool it with usually lake water. Okay, you can see the water coming in from the river or the lake. This gets cooled. And then what happens is the steam, like the water, turns back into a liquid in the condenser here. And then it goes back to be reheated again and keep the turbine spinning. And so the deal is you will get, like, as the water cools, it can boil off the water that's coming in from the lake, and you get this water vapor that comes out of the top of the smokestack. It's not really smoke though, it's just water vapor. So this is clean, right? That's not a greenhouse gas, water vapor. There's lots of that in our atmosphere already. So you can see, like, you don't get any burning of anything, so there's no carbon emissions from this process. Okay, so that's basically how the reactor works. Remember, just trying to get the turbine to spin. Now, what are the pros? What are the advantages of nuclear power? Actually, there are several. Number one, it's reliable. Now, what that means is it's available anytime you need it on demand. So if I'm a reliable teacher, then, you know, what we mean in this context is that you could ask me a question at any time and I would come up with the answer any time. If the weather's bad outside, that doesn't mean I'm not going to answer your question, okay? So that kind of, it's raining or whatever. But the thing is that there are sources of power that are less reliable. for example, the solar panels on my roof don't work at night. And so I need energy at night, so I can't only power my house with solar panels. So solar panels are less reliable, which means they're not available all the time. Wind power is like that too. It's not just available anytime. Whereas nuclear power, you can just turn it on and off. You can ramp it up if you need more power, and you can do that anytime you want. It doesn't matter where you are in the world where you build your power plant, right? How much sun you get or anything is not weather dependent. So what it means is nuclear power has no weather constraints and can run without disruption in any climate. So it's reliable. So that's an advantage. In fact, all the thermal generation systems are reliable that way. It's just wind and solar that are not available all the time. Wind depends on how windy it is, okay, and solar depends on how sunny it is, of course, and that's affected by the weather, and we can't control the weather. All right, nuclear power is actually, surprisingly, maybe, has a low operating cost. Okay, so the fuel costs of a nuclear power plant and stuff are low. And so this can be generated very economically, nuclear power. Nuclear power has very low greenhouse gas emissions. Okay, so like you're not releasing a lot of carbon. Coal, gas, and other electric power plants do produce a lot of carbon. Nuclear power has the lowest greenhouse gas release. And look, we have to look at greenhouse gases in terms of the total chain of events. So when you build the reactor and when you transport and mine the uranium, there will be carbon emissions in those processes, just not in the reactor itself. Okay. So when you look at it as a total, the like sort of totality of it, it has very low, only 4 grams of carbon per kilowatt hour, which is extremely low. You can get coal, which is like hundreds of grams. Okay, so a kilowatt hour, we'll talk about these units later, but that's how you measure electricity. So those are 3 pros. 3 pros of nuclear power. It's reliable, the cost is low, and there's almost no greenhouse gas emissions. Now, what about the cons? Well, there are some cons to worry about. Okay, nuclear power plant does have an environmental impact, okay, in relation to the mining of uranium. So you have to mine and transport the uranium, and that means you will affect a geographic area when you build a mine. Okay, you could contaminate the surrounding environment, okay, in the process of mining. In the process of refining, you'll release some carbon dioxide there for sure. And of course, in the transportation of it. Okay, nuclear power produces radioactive waste. Now, I would change my wording here. It does not produce a lot of radioactive waste. Okay, it does produce radioactive waste though. And that radioactive waste is all solid. It's not gas. It doesn't go up in the atmosphere. But it's highly radioactive and therefore highly toxic. Okay, and if you get a contamination of your area or your city with radioactive waste, that's not good. That happened to a city in Ukraine we call Chernobyl. And in Chernobyl, what happened is the power plant had a nuclear meltdown. It sent a cloud of radioactive dust up into the atmosphere and contaminated the entire area with radioactive dust. They had to evacuate this town or city of 300,000 people. Okay, and they had to do it in a space of 48 hours. So, you know, the town that time has forgotten, right? Like if you see Chernobyl today, I'll show you some pictures tomorrow. It almost looks like a scene from like an apocalyptic world or something where there's no people there. Everyone just left. Okay, so I wrote this too. It can be dangerous in the wrong hands. So if you have radioactive waste, you can make what's called a dirty bomb from it. A dirty bomb can be like an extremely dangerous thing, and that's why we don't like countries that have unstable political systems to have nuclear power. The problem is like what happens to a country that maybe some sort of rogue operative takes control, or they don't have good security, and someone steals some radioactive waste and now makes a dirty bomb, and now you can have like an entire city or area at risk because someone's carrying around this extremely toxic radioactive material that can be used to make a bomb. Okay? So that's definitely a con of nuclear power. It does not produce a lot of waste though. Like that definitely is part of the pros of nuclear power, is that the amount of waste is very small for the amount of power you get. Okay, like a nuclear fuel cell the size of my fist would power my house for many, many years, probably 10, 15 years. And that's all the waste it produces. It would be about a mass of radioactive waste that is equivalent of the size of my fist. Okay, so really it produces very little waste in terms of mass, but the waste that it does produce is extremely toxic. All right, there is a risk of nuclear accidents. So Chernobyl, for example. Chernobyl is a town where they had this really tragic accident, and it spread radioactive dust throughout the region. And to this day, you cannot live there. If you were to live there, you could get cancer, and you will not live very long. Let's put it that way. I mean, you might live for 10, 15 years or so, but then you're going to have all kinds of, you have a compromised immune system. You'll get sick really easily. You could develop tumors, like malignant tumors in your body, and get fatal forms of cancer. And so for us to live there would not be possible now. So, and that's going to be like that for maybe thousands of years. Okay, that whole area. So this radioactive waste can pose serious health effects, okay, on the lives of people and the environment. And it also lasts an extremely long period of time and is difficult to clean up. Okay, so those are the cons of nuclear power. All right, so you get the idea. I would like you to do what I did here. So a brief description, like what you see at the top, grade 9 level description, and then 3 pros and 3 cons. You will find all of this in your textbook. Okay, it's all in your textbook. So can you use the internet? Yes, that's fine. If you want to use the internet, use the internet. But please do not copy and paste stuff and expect that to be your assignment. Look, I can tell when it's in your own words. And I'm going to read this one and give you a mark. Okay, it's not just a completion mark. So please do a good job with it. It's a very interesting topic, and for our society today, it's a very relevant topic. Okay, so please, in your own words, describe it. So you have to read it first, write it in your own words, and then also write the pros and cons in your own words. So use the internet as a resource. Use your textbook as a resource. I would use the internet, if I was doing this, I would use the internet to find the photos that I wanted, and then I would just describe it based on the knowledge I acquired from reading about it. Okay, now whether you read about it online or in your textbook, either way is fine, but just make sure you're at the right level for yourself. Okay, most of these are pretty easy to explain how they work. I did the hard one here, nuclear power. The rest of them are easier than that. Okay guys, that's it for today. So like your assignment is basically to do that, and I'll remind you again, in case you didn't hear me the first time, that the stuff I highlighted in yellow, except for the calculations worksheet, the stuff that you see highlighted in yellow here on this page, Monday, okay? If you could please get it done for Monday. Now tomorrow, I'm just going to, fair warning, tomorrow I'm going to add this one, okay? But please, for Monday, please have that finished. And then we're getting close to the end of electricity. There's only a couple of things with circuits next week. Then we're going to finish it, and we'll start ecology after that. But that means we'll have a test coming soon. So please prepare for a test next week. Let's say towards the end of the week for electricity. Okay, so please be ready for that Thursday, Friday next week test on electricity. And we'll be wrapping things up by then. Okay guys, so that's it for this. Have a good day, and we will see you tomorrow.